Could Mars once have supported life? Mineral evidence from probes like the Spirit rover is encouraging, but it can be radically overinterpreted.
We have to be careful not to jump over a line that goes beyond what the current data, the current experiments, the current hypotheses can support. But it's hard as human beings not to just jump over that line.
In 2008, thousands jumped to an incredible conclusion when a picture taken by NASA's Spirit rover goes viral across the internet. Doesn't this figure look amazingly like pictures supposedly taken of Bigfoot? Is this proof of life on Mars? No. It's a 2-inch tall rock.
We still do not have definitive evidence for the existence of life on Mars ever.
Like the 19th century canals and the 20th century face, the Martian Bigfoot is a 21st century trick of the light.
And sometimes people don't know how to distinguish between the facts and the science fiction.
If there is or was life on Mars, it probably evolved very early in the planet's history, when Mars still had a magnetic field shielding it from harmful space radiation.
The evidence that Mars used to have a magnetic field lies in the crustal rocks. Most of the crustal rocks have a magnetic field frozen in when they solidify.
These magnetic rocks, scattered across the red planet, give Mars its own version of Earth's northern lights, as discovered in 2008, although it may not register as visible light to human eyes.
On Earth, when charged particles from the sun get trapped in Earth's field lines and smack into the atmosphere, they cause the atmosphere to gain energy and then emit a glow. The European spacecraft Mars Express recently detected aurora on Mars. And what's actually happening there is that there are charged particles streaming down magnetic field lines being made by remnant magnetization in the crust.
But how did Mars lose its magnetic field? One theory, a little less than 4 billion years ago, as Mars cools, its molten iron core solidifies and stops turning.
The motions within the core weren't sufficient to generate an electric current, producing a magnetic field.
But there is also a faster and far more violent hypothesis.
Another more recent idea that's pretty controversial is that Mars had one or more fairly large moons that were actually captured satellites. And those moons tidally heated the interior and kept it molten, allowing currents to be generated and thus producing a magnetic field. Now, if a 500 million years after Mars's formation, those moons crashed into the planet, that could have destroyed the magnetic field.
For most scientists, the pieces of the impact theory don't fit. Could satellites large enough to do such damage lose enough inertial energy to be captured in the first place?
This idea that Mars had moons that crashed into it within the first 500 million years is pretty unlikely, but it's not completely impossible.
Questions about Mars' magnetic field and the search for life intersect here. In the Martian meteorite ALH-84001. In 1996, some scientists say it contains fossilized Martian microbes. More scientists say the objects are non-biological.
All the time since then, people have been working on this poor little potato-sized meteorite, extracting more and more information. But there's actually has some new results being presented.
In April 2010, researchers with new radiometric tools announced that earlier estimates of the meteorite's age are wrong.
It's actually younger by 500 million years than we thought, roughly.
The older date had placed the rock at a time when Mars was still solidifying, maybe too early for even microbes to have evolved. The new date places the meteorite at just under 4.1 billion years old.
That, of course, is the time 4.1 billion years ago when, if you thought Mars was habitable, that would be the time you would choose. Because we think there was water flowing on the surface, and it was warmer, and there was a thick atmosphere.
But how can a meteorite from Mars end up on Earth? That's what Christina M. from Dallas, Texas wanted to ask the universe when she texted us, what makes part of one planet fly off and land on another?
Great question, Christina. We've actually found meteorites here on Earth that are undeniably from Mars. There's about 50 of them known. Well, what we think happens is that asteroids occasionally slam into Mars and throw chunks of rock out into space, and Earth's gravity can also pull them in. So they land here, and we find them, and in this way we can actually study pieces of Mars here on Earth.
In 2010, NASA announces that more advanced electron microscopy of ALH-84001 reveals new details of iron oxide crystals called magnetite, a mineral within its own magnetic field that on Earth can be created by certain ocean-dwelling bacteria.
Bacteria here on Earth have figured out how to grow magnetite crystals in their own bodies that help them to orient to the Earth's magnetic field in order to help them swim in the ocean and orient while feeding.
Are the crystals in ALH-84001 fossilized magnetite created by Martian bacteria to help them hunt and feed in an ancient ocean when Mars still had its magnetic field more than 4 billion years ago?
If they are fossils, of course, they'd indicate that early Mars had a fairly sophisticated life.
That's still being batted about, and bottom line is there's still a heck of a lot of scientific work being done and a lot of debate about Mars meteorites and whether there's any evidence